try to make sure we have some time for that.
Does anybody know where we dropped the Microsoft Pragmatic and the Terra?
Yeah, I still got mine. I haven't found them yet.
Okay.
I started to wonder if they were on another floor,
Right.
but most of the vendors were on the bottom floor, so I'm not sure.
Pragmatic said they didn't have a table.
Oh. Oh, okay. And Microsoft, I know somebody from Microsoft came by and dropped off a box of stuff in the speaker room, and somebody said, "Hey, there's Microsoft stuff here." I'm like, okay, well, someone was here.
The thing is, it's in there.
Yeah.
So,
Yeah, you can drop my card anywhere you want.
Circular file?
Yeah.
That's right. Trust me, I know. And I'm not even at the same level there.
I've been doing this for 35 years.
Are you serious? Oh my God. She, well, she's...
I had people measure in their offices one time. Can the offices sit there?
Surprised you're coming to this session. You could teach me a few things.
Different places.
I saw that.
And she was definitely
I'm coming to your session to support my friend.
I
Okay.
mean, the other ones were always...
That's one of the fun things about conferences and days like this.
Yeah.
No
We'll
clue
see each other's
about
sessions.
police
And
harassment and
I went to a
stuff.
session this morning where I learned a lot. Beginning with big data and BI.
oh, wasn't that? It was Carlos, wasn't
Yeah.
Yeah.
Carlos did a fantastic job
it? Yeah.
explaining MapReduce and how that's the central part of big data and so on. Best big data talk I've ever seen.
He had one of the campus, it was not a dean, but it was one of the heads of that division of computer science for this campus came in and congratulated him, wanted his information, wants him to come back and do speakings. He must have done a stellar job.
He did. He cut through the hype and made it very, very clear and simple. He could have actually stood to add a little hype in.
Yeah,
Really.
it's cool.
Well, we'll go ahead and get started. I'll just go through the introduction part. That way, if people want to come trickle in, they can, in case they haven't gotten all the way down the hallway. This is Make Your DBA Happy, 5 habits developers can implement today. My name is Eric Ozakowski. I'm going to go over basically just some technical habits and best practices that we can do, and also some behavioral ones that we can implement. This is meant to be a developer session, and this is also meant to be a very beginner session. If you're an experienced, accomplished developer, just keep in mind that a lot of these may be skills and practices that you've learned years ago, and you may already be using. If you're a brand new developer and you want to learn what others are doing that are kind of good best practices or good habits to get into, this is a great time. You're in a great spot. But some of this may be old news for you. If you're used to this, you're an experienced developer. If you bear with me, you might remember some of these good habits and think, yeah, maybe I can do that. Or you may be already doing those and you can support them. So we'll get started. 5 habits is the topic. The 5 habits we're going to go over are database construction and housekeeping. We're going to talk about application habits. We're going to discuss what happens when we assume. We're going to discuss bridging the role gap, and I'll explain that later on. And then finally, relationships. As you can see, 2 of these are more technical, and the other 3 are more behavioral. The technical portions, obviously your language of choice is your own, or based on your company that you're with, or the practice you're in. For the sake of the demonstrations and examples, it's going to be C#. But it's going to be very high level. I'm not going to do a lot of code demos. I do have one demo that's very brief, but it's in SQL using SSMS. But it's a very high level class. It's not, or a high level session. It's not meant to be a deep dive into code. It's not meant to be a very technical session. This is a real high level session, more about good practices and good habits. Let me tell you a little bit about me before we get started. I started programming in 1982 on the old IBM 3088 and 3090 mainframes, long before the days of the internet, back when modem banks were actual phones and there were tape drives, and it was interesting. I first started using SQL in 2006. I was using SQL 2000, at that time. Currently a SharePoint software developer for General Motors, and I'm also an independent contractor. I do more with General Motors than I do independent contracting, but that's good. And if you're social, that's my Twitter handle. I'll have that up at the end of the session with a lot of links to references. This slide deck is available online. I'll give you the link to that as well. Also the slide deck, I published it to the SQL Saturday page. So if you go to that page where all the other people's slide decks are, mine's up there too. So let's start off talking about database construction and housekeeping. I'm going to talk about 5 different things within this category alone. The 5 high-level ones pertain to best practices and good habits, like the slide deck says, but I found 5 topics I can discuss inside data construction and housekeeping. The first one being indexes. Next, we're going to talk about data types. We're going to talk about recovery models and logging, and this is a whole other subject altogether, but I'm not going to go into a lot of depth into this area. I'm going to do a real high level, this is what it is and this is how it works, and your choices will impact not only your DBAs, but also your application, and we're going to talk about that. Use of queries versus views, and also the use of select star and select distinct. So first let's talk about indexes. Indexes pre-materialize a sort over the data. So if you are constructing a query for a report or for an application that's going to present data to the screen or your website, and you want to have a sort already built into it, you want to optimize this, you would use an index. It speeds up your sort by criteria in your query, and it also enables seeks for particular values. Now before I go on, I want to talk about the difference between seeks and scans. Again, very high level. Seeks are better than scans. Each has its application. Scans are good for large amounts of data that's organized well. It can scan through and it will return the data in an efficient manner. However, for the majority of what we're doing as developers, a good practice to keep in mind is seeks are better than scans. Scans will increase the number of locks on your database or on the tables, and they can be held longer depending on the query runtime. So for example, if you have a non-indexed table, has a ton of data in it, and you run a query against it, and the results of that query are going to impact the next decision in your code, your next decision isn't going to take place until this is done. This could show up in your application as a performance issue. Somebody could say, hey, this website takes forever to load. How come my phone app just sits and turns and turns and turns? It could just be because you need an index. It could be as simple as that. I mean, it could be, and we'll discuss this later on, it could be the code needs to be refactored. It could be you have improper joins. I mean, there's a lot of possibilities, but it could be as simple as you just need an index. Oops. Go back. There's many ways to analyze performance in a query. A lot of tools available. Redgate provides one that I love called SQL Toolbelt that has a ton of really neat performance analysis tools in it. We're not going to go into any of those. I'm going to discuss the execution plan. Query Analyzer is another one, but I'm going to do a demo on using the execution plan, which is a part of SQL Server Management Studio, or SSMS, that ships with SQL. So what I have here is just SSMS 2008 R2, and what I'm going to point out is this just simple query that shows, select 2 fields from a table where the date is between X and Y, order by the date, because I want to see the most or the oldest transactions first and then the newest ones, and I just want data. It's that simple. This table, just for your edification, has 77,000 rows in it. We're not talking about a huge warehouse. We're just talking about a simple little table, 77,000 rows in it. But I want to point out this icon, if I can get my pointer to work. I guess it's not going to work. I'll point it out with the arrow. This one right here, no, where am I? Here. This one here, it says include actual execution plan. Now, this one on this side is to display an estimated execution plan. They both do the same thing. The first one is going to guess at the impact to performance based on what you've built into your query. The other one is going to tell you exactly what happened to the server after you execute the query. We're going to use that one. So I click on include actual execution plan, and I'm going to launch this thing. Oh, shoot. Let me fix that. Okay. Okay, so I've got my data back, I've got everything I needed, and now I've got an extra tab here with execution plan. When I click on it, notice what happened. It showed me what happened with the results of the query, but it's also telling me I'm missing an index. If you look backwards, 89% of this query was taken up with a scan. Remember I said seeks are better than scans. So 89% of this query was spent with the database scanning through all of your data to try to find information that fell into my where clause. Then it spent 9% of the time sorting that data. The remaining part of the time was gathering everything information into my select statement so that it could present it on the screen. So basically what we're looking at is 89% of this query was spent scanning my table. Maybe not the most efficient way of doing it, but I'm going to give you a measure that you can use to determine its efficiency. If you mouse over this select statement, we can see what actually happened. A lot's going on here. And the more complex your query goes, the larger this pop-up window is going to get. I don't want to spend a lot of time talking about that. The one thing I want to point you to as developers is the estimated subtree cost. This is a measure that you can use to determine a baseline versus did it improve or did it not improve as you modify your query for performance optimization. Again, not a query performance optimization session. We have one of those. I think there's a couple of them here today. But I'm not going to go into that level of detail. All I'm going to show you is consider this your baseline, pre-index. So it says 10.7. Now, if you notice in red, or in this other, I'm colorblind, so I'm assuming it's red. If you notice in red, it says missing index. If you right-click on this, if prompted, and go to missing index details, it's going to construct the creation of an unclustered index for you based on what you put in your select statement. So at this point, all you have to do is select this. Well, don't do that. Select the create statement. I mean, you can select the database too. But the create statement and fire it, hit execute, and it's going to create an index. Obviously, you would have to give it a name here. But give it a name, a unique name. It depends on your organization. Some orgs will call it, IX underscore friendly name, or NCI. I'll use NCI a lot, non-clustered index, so I know for sure that this was mine that I built. Or you can prefix it with the job name or the database name, or whatever is easier for you. But give it a unique name, but allow it to run on the database and the field that you need to index on. The include is if you want to include that field as part of the reference when you're indexing, that's fine. It's not required, but in this case, I'm going to leave it in there. So I've already built this into my little script here. So I'm going to fire this creation of the index on this table. It's done already. Now when I go back and I run this same query, I haven't touched the query at all, and I look at my execution plan, now look what it did. 100% of the effort of that query was spent in an index seek. Now it looked like it took just about the same amount of time. It just, boom, we got our data. It was quick. You're right. But when you mouse over the select statement, look at the subtree cost. We went from 10.7 down to 0.07. Huge performance impact on the database. I'm only talking about 77,000 rows, and in this case, I'm only asking for 27,000 of them. What happens when you're dealing with millions and millions of rows? I heard somebody say today that one of the people who works at SRP, billions of rows of data. What's going to happen to your query when you have billions of rows of data? Huge performance impact.
Does that missing index recommendation happen by default, or do you have to turn something on for that?
Happens by default. But, and this is one thing that I had a discussion with a colleague of mine when I said, well, I could literally just let SQL tell me when I need to create an index. I could just create queries, and if it says I need an index, just create an index. Does that sound right to you? And he said, well, yes and no. You could do that, because SQL is not going to tell you to do something that's going to be destructive. However, is it wise to have 30, 40, 50 indexes on a table? Not really. Will you see a performance impact? You could. If those indexes aren't maintained, which we'll discuss shortly, if they're not rebuilt, reorganized, it could have a performance impact. Is the fact that SQL now has to comb through all these indexes to find which one you might be wanting based on the selection criteria an issue for performance? It could be. But the trade-off is, when you're querying that much data, is it better to have a view and have the data prepared in a view instead of using indexes? Is it better to use indexes instead of a lot of views to save space? Something you need to discuss with the DBA. Sit down with the DBA and discuss what's their plan. How does the DBA, and a lot of this is going to be centered around getting devs and DBAs together, working together to build a final solution. Is having extra indexes a good practice? Is it better to have another table with separate indexes? Is it better to have a view and then index the view? That's a discussion you should have with the DBA. But we'll go over that a little more also. The base thing I want to take away from this, and I'm going to go back to...
Eric?
Yes?
I just wanted to add when you're creating more indexes, that speeds up reading. It does slow down writing because there's more disk I/O that will occur.
Yes.
Now, with modern OSs and SQL Server, there's a lot of write-back caching that occurs, so it may not have that much of an impact, but every little bit adds up, and you can wind up creating a disk bottleneck. So it's
Right, and that's kind of the discussion I had with, it was a fellow from Statera. That's kind of the discussion I had before was, you may or may not see a performance impact, but the more indexes you create on a table, you can't go crazy.
Yeah.
You don't want to just go nuts and just create index after index after index. At that point, if you're creating that many, start thinking about creating views. And we'll go over the difference between complex queries and views in a little bit. But yeah, you don't want to go nuts and just create tons of indexes. Will SQL tell you about this as you're constructing your queries? Oh yeah, that'll come up automatically and it'll tell you missing index. And it's handy, but it's not always the final answer. Look at your query, maybe change your query around a little bit, but definitely exercise this in a dev environment because it's your environment anyway. And then sit down with the DBA and discuss if that should be put into a view or if extra indexes are appropriate. But good point, David, thank you. And then for the sake of the slide demo, I put in the before and after shot and then pointed out the estimated subtree cost. So that way when you guys take the slide deck away, if you want to download it or use it later on, you'll have this discussion that we had. Indexes need maintenance too. It's kind of like running defrag on a PC. At some point, when you run your index and it indexes all the data that was in there, and now new data gets added, it gets tacked onto the bottom. So initially, is it an issue? No, not really, because the database has enough intelligence to comb through the data and say, oh yeah, I see this is down here, and it'll return the data as expected. But over time, and depending on how many transactions you have, over a short amount or a long amount of time, it's going to get out of sort. It's going to be kind of like I said, like a defrag on a PC. It saves file data, but it scatters it across the hard drive, and eventually you need to group it all together into an organized fashion. DBAs will do this using one of two methods. They either do a rebuild or they'll do a reorganize. Typically, this isn't something the devs are going to do, but I want to make you aware of this because it's something you might want to do on your dev environments to get used to it, but also so you can get familiar with what DBAs have to go through when they're maintaining your indexes. A rebuild is good for a regularly scheduled downtime, like a maintenance window or an outage window, a server maintenance. The reason why is because it builds a brand new index every time. So if you can imagine this massive database with 10 million rows in it, and you have an index on it, and there's transactions constantly hitting this database, and it's getting disorganized, it's going to take a while for this thing to be completely destroyed and rebuilt from scratch. And it's something to keep in mind, that this might be the best answer for a DBA to say, I want to rebuild this index, but I can only do it during an outage window because while it's down rebuilding, that table's inaccessible. So your users, obviously, if it was during the day, it would be very inefficient. It can be time consuming depending on how big your table is or how complex the data is, how many columns you have, etc. The other option is a reorganize. A reorganize is more lightweight. It just kind of, like it says, reorganizes the data that's in the index. It doesn't require a massive rollback if canceled. Let's go back to the rebuild. The rebuild, if you hit the stop in your SSMS while you're rebuilding an index, it has to stop and cancel the operation. If you've ever done this and you have something you're firing and you think, oh, I really didn't want to do that, and you hit stop and it says canceling, and it sits and it runs and it runs. It has to roll back that transaction. If you're doing a reorganize, you don't have that. The reorganize just stops where you left off, and then if later on you go back to it and fire it off again, it just picks up where it left off. So you don't have that massive rollback if you want to cancel it. The key thing to take away from this is when you're adding indexes to your development tables or your development views, let your DBA know before you hand them the scripts to launch those or to create those views and tables. Because they usually, not always, but usually have a job that goes out and rebuilds and reorganizes their views and their indexes. If you don't let them know, you just hand them the script and say, here, fire this, and they may or may not be skilled enough to look through the script and say, yeah, everything looks legitimate, go. Now they're missing an index on there. Your applications could suffer, the database could suffer, as you've seen, by looking at the subtree cost, and they'll never know, and you'll never know. I want to talk about data types next, and the impact of selecting improper data types. Well, we'll explain in a bit, but you're going to see significant performance implications by not selecting the proper data types. You're going to create wasted space and I/O issues. We should also be aware of Unicode data types, and I'm going to talk about that separately as well. First thing I want to talk about is performance and wasted space and I/O. This table just shows an example, and again, this will be available to you guys whenever you want to download it. This is just a snapshot of some common data types that we might use in our tables, and the types of values that are stored and their storage requirements. The biggest thing I want to point out with this is the data type and the storage requirements. The value stored is just for your information. But if you look, some of these only take 1 byte. One is 1 byte per 8 bits. I mean, it's nice and small. It seems relatively small. Let's put this into a table and see what the actual impact is. So for the first example, I've created a table. It has a primary key, it has a number, and it has a date. Okay, an int and a date time. And then I put a identity on it, so there's a primary key set for the table. The bytes per row, if we add it all together, the int was 4, right? The second int, because I got the primary key, the second int was 4, so now I've got 8. The date, which is a date time, takes up 8 on its own, which is now 16. And every row in SQL has 9 bytes of overhead. So now I've got a total of 25 bytes. Again, seems pretty small. SQL will perform its transactions using data pages. And you can fit 8,096 bytes per data page. So we divide that into, or divide our total bytes per row of 25 into one data page, yeah, we've got 323 rows that we can fit in that data page. Consider that over 1 million rows. Now we've got 3,096 pages that SQL has to make to pull your data back. Okay, let's use this as a baseline. But this time, let's change the anum and the adate columns to different data types. This time, instead of an int, let's use a tiny int. And instead of an adate, let's use a small date time. This is assuming, of course, that our anum number is never going to get larger than a huge value, like it's going to continue to grow like a primary key. And let's assume that a date doesn't need to be a date and time stamp. It just needs to be a month, day, year, date, simple date. Given those requirements, we can change the data types to tiny int, small date time. Now look at the impact. The bytes per row is now only 18 bytes. The rows per page is now 449 rows, so it's already more efficient. But after 1 million rows, now it only takes 2,228 pages to return the same data as opposed to before. So in the end, we've saved 27% of the space. And a single I/O on that database can return an extra 126 rows. We've improved performance by 39% simply by changing 2 columns to different data types. Huge impact on performance. You're going to notice it in your applications. Your DBA is going to notice it when their CPU time and their I/O time goes down. Your end users will notice it when your application runs smoother. It's a huge impact just by picking the right data types. One thing to consider, though, is you might need specific data types. That, of course, is between you and the business, or you and the consumer, you and your requirements. But if you don't need a date and time stamp, why not use a small date time? Or a date, for example. If you don't need an int because you don't need the giant number, why not use a tiny int? Because you know it's only going to be a number between 1 and 4, for example. Why not pick those smaller columns? Because the subtle little changes are going to have a huge impact on your end performance as this database grows.
be live and there should be no downtime. That's, again, something you have a conversation with the DBA with, because they're gonna understand the threading and the IO cost and the CPU cost of the server. You understand the effects of the application, who's gonna be using it, because you had those discussions in your requirement sessions with the customer or with your project manager. And in the end, you can come to an agreement on, I think this would be best because. And later on, I'll discuss, when you're sitting down with the DBA, having those discussions is a trade-off, because you're sharing that information, you're educating each other, you're just making each other better. Yeah, good point, David. I'm glad you brought that up. Unicode versus non-Unicode types. Something I never thought of when I started developing years ago. Actually, like front-facing applications, not the mainframe stuff. But Unicode versus non-Unicode data types. Basically, Unicode is used for storing special characters. It's a good way to think of it. However, Unicode requires 2 times the storage as non-Unicode. For example, let's assume you have a varchar field of 300. Now, let's say you're going to store an address or postal address or something in your email addresses or something. And you have a varchar field that's 300. That's 300 bytes per row. It's a non-Unicode field. An nvarchar of 300, same thing, but that requires 600 bytes per row because it's Unicode. It has to account for the special characters. Yes, sir?
Up to 300 bytes.
Correct.
Because the varchar is
Scalable.
Yeah.
Yes.
Actually, there's also a little bit of overhead with it.
Right, but let's assume that it's fully populated.
Yeah.
The extreme, I'm going to extremes. Of
Okay.
course, there's, if you store, 4 characters in there, it's only using 4. But for the sake of this, let's assume that you filled it to the max. In this case, and again, David would say an extreme example, but for 10 million rows, your nvarchar now requires 3 gig more space than your varchar. Again, extreme example, but look at the impact you're having on your database and on its storage based on the decisions you're making with your data types. Data type choices are very important. Your nvarchar, nchar, and ntext should only be used with columns of international text. However, that's a good practice, but consider what you're building. Each has its own specific application. Let's assume you have a front-end website, and right now, you're only using English-speaking, you're only expecting English-speaking users to hit this. They don't have any special characters in their keyboard, no special characters in their language set, so you're not going to expect that. And you can use a varchar. That should be fine. However, 2 or 3 years from now, your company may want to expand to other markets, and they're going to use special characters, and now you're screwed, because you should have used different data type. And is it easy to convert between data types? Not always. Sometimes you need to grab somebody like a David to come in and transform your data. You need to grab a consultant to transform your data, and it can be costly. These are things you should be discussing not only with the DBA, but with your project team to make sure that it's scoped properly. However, let's talk about back office data management. Let's say, for example, you have a simple back office application that you're building for your internal users, and all of them have no special characters in their keyboard or language set, and it's just going to be data used by your company. That would be a good example of using non-Unicode instead of Unicode data types. You're going to save a ton of space. It's going to help your application perform better. You know it's not going to scale out to be something that's going to require international text or special characters. That would be a great use case for that. Recovery models and logging. Again, there's 3 different recovery models available to us in SQL. I'm only going to talk about 2 of them because we could go into a whole hour discussing recovery models and logging, and it's more of a DBA level discussion than it is developer. I want to get you familiar with what DBAs have to go through so that we understand the decisions we make are going to affect them and our application. The first type I want to talk about is simple. This is, as it says, the most simplest recovery model. There are no log backups. It automatically reclaims log space to keep space requirements small. And it eliminates the need to manage transaction log space. Every time we make a transaction against a database, that event is stored in a transaction log, and I'll explain why in just a second. The problem with simple recovery model is changes made since the most recent backup are unprotected. And again, when I go into the full, you'll see why that's important. If you have a development database that you're just toying around with to see how you want the data to be constructed, how you want it to be stored, etc., then this would be a good choice because you're not having to deal with transaction log overhead, space issues, etc. You just need a place to play, like a sandbox. The full recovery model requires transaction log backups. The nice thing is when your DBA runs the normal backups on that database, the transaction log is automatically shrunk. So you don't have to worry about eating up a lot of space. No work is lost due to a lost or damaged file. So if you have a problem between change 1 and change 2 on a full recovery model, and you call your DBA and say, wow, this really messed up, I need you to roll that back, they can roll it back and you won't lose anything. Really handy. However, it takes up space. So it can recover to a specific point in time, assuming your backups are complete and current and up to that point in time. Again, something you would work with your DBA with. The third type is called bulk logs, and again, we're not going to get into that. There's plenty of information available like that in MSDN and online, but the two I want to pay attention to are simple and full. The main thing I want to take away from this as developers is you should always let your DBA know which model you chose in development and which one you want to use in production. You may be the type of environment that wants to use simple in dev and full in production, and that's fine, you should. I would encourage that. However, if there's no regular transaction log backup set in your database on a full recovery model, that transaction log is going to grow and grow and grow and grow infinitely, and you're not going to notice it until your DBA is noticing performance issues, your application is sluggish, and the reason why is because it's taking up free space and bogging down the I/O. The read-write time is going to go way up. Yes, sir?
I went into one client years ago and they had put up their server about 6 months prior, and they were in full recovery mode, and they had not made a transaction log backup. And so guess what? Their transaction log was as big as their database.
Oh yeah, I believe it. I believe it, and that's scary. You can't.
They discovered it the day before I came in to do the health check, and they decided to leave it just as a little test.
Just to
Just to make sure.
That's.
It was definitely something I couldn't avoid missing, but anyway.
Well, it's unfortunate that, you know, and a lot of this stuff I learned from DBAs, from people who deal with this on a day-to-day basis. They said, my gosh, if the developer would have just told me that they wanted a full recovery model when they handed me the script, and I just looked at the script to make sure it wasn't malicious, and I hit execute, and I didn't realize they wanted a full recovery model because I wasn't looking for that. I assumed that they knew what they were doing. And a lot of the times it's just because the developer didn't even realize it. We didn't realize as devs, we're focusing on our code and its performance and passing unit tests. We're not realizing or not thinking, well, the DBA might need this or might need that. And I want to bring that back and say, let's make sure we understand that the DBA has certain requirements, just like we have certain requirements when we're building our applications. And this is one of them. If we're choosing a full recovery model, transaction log backups are an absolute must. Otherwise, your free space is going to disappear. I want to talk about queries versus views. Putting complex queries into stored procedures or views, as opposed to putting them into your application or website, is an absolute best practice and should be exercised regularly. As convenient as it is to say, select column A and B from table where this exists and just stick it in your code, because it's just easier to deal with than having to build a stored procedure and parameterize it and then write that in your code. It sounds like a pain in the butt, but it's going to save you in the long run for numerous ways. I'm going to explain that. You not only have to consider the performance implications and benefits of putting large queries into views, we also need to consider, I'll go into this in just a second, we also need to consider who's going to be accessing these queries should things change. You would like to have a centralized location where your queries are taking place so that both you and the DBA can look at it if things should change, like columns get dropped, columns get added, indexes change, data types change. This is something that both you and the DBA should be able to look at, and it'll be a lot easier to modify it in the database than it is to pull your code out of source control, look in the code to see if you can find it, mark it up, pass it through unit testing, pass it through QC, and then pass it to prod, tuck it back into source control, and hope nothing else broke when you opened it up. Oh, let me go back. I'll show you that one in a second. You can also index views. We just need to remember to let the DBA know so that they can maintain the index during the rebuild or reorg according to their schedule. And if you're familiar with common table expressions, it's a lot like a subselect, a little more complex. These are useful, but they're not always the answer. The next screen that I passed up here is an example of an actual query, and the reason why it's nearly illegible is on purpose, is because this is an actual query that pulls data out of a BI environment that's massive, that wants to look at maybe a handful of columns. But the query is necessary to massage the data in a way so that it's understandable. It would be a lot easier if we just needed a couple of columns out of this to say that, wouldn't it? Give me a couple columns from that query turned into a view. Because now I can expose those columns in a view, just query the view, and it's lightning fast. Because the view is already pre-compiled, pre-sorted, based on whatever index criteria I gave it, based on whatever filter criteria I gave it, and it's already ready for me. It provides a centrally managed data set that both the DBA and the developer can look at together and determine if it's performing properly, if the data types are right, if the columns are organized properly, if the index is correct. It brings those two together. It also allows you to communicate effectively regarding changes as well. So like I was saying before, if the vendor comes in and modifies their database without telling you, because they would never do that, and they drop a column or they modify a data type, and suddenly your application acts bizarre, you can sit down with the DBA and say, hey, can we look at this view because this isn't acting right. My query is not acting right. It's pulling back weird data. I'm getting duplicate data. I'm getting null. You two can look at this and you will have commented your view, because again, commenting is essential. It's a pain in the butt, but it's essential. You've commented your view to say, this view is supposed to do this and it's supposed to pull this information back. Your DBA can look at it and say, well, he's expecting this, but this is what it's giving. So let's go through the view and make sure that nothing changed. Let's compare that to the database because the DBA sat in that requirements meeting when the vendor came in and knows exactly what happened and can go through this and say, well, this is what your problem is. This data type is no longer this, it's this. Let's change it and then experiment with it. It opens that dialogue up and makes things a whole lot more efficient. It also eliminates the need to hunt through code for potential impact. Again, if that giant query was in your application, sure, it would work. But is it easier or more efficient to have the DBA open up that view and just pick through it and modify it, or is it easier to pull it out of source control and go through the whole process I explained before? A lot easier just to sit down in front of the database and look at it. I want to talk about, I'm sorry.
You keep on saying how much of a pain in the ass source control is, but
Yes.
what kind of versioning do you use instead of that when you want to see historical changes to those views?
Good question. I put, as a personal practice, I put my views and my stored procs and my data table or databases and tables in source control. Redgate has one called SQL source control that I use. It's really slick. Any changes you make are going to get stored in there, and then you can pull that up in that source control window in SSMS, and it integrates right into SSMS. And you can pull up and see historical changes. You can make comments against it, just like you do in TFS, just like you do in SVN or in Git or whatever your flavor of source control is. That's what I would use. And by pain in the butt, I'm saying it's more effort to pull it out of source control and modify the changes and then have to throw it in dev and then throw it in test and then give it to QC and make them sign off on it and then hand it off to them for prod and then put it back in source control than it is to sit down in front of the screen with the DBA and have them say, oh, just change this to this. He tweaks it, writes it back to source control, the problem goes away. That's my takeaway from it is, to me, it's less effort to do that, and it keeps that dialogue going between the DBA and the developer than it does for me to sit down at my machine, modify my code without even telling the developer, just to try to make it work. Because I might have had good code to begin with, and it might not be my fault. It might be the fact that just the database changed. Select star and distinct. This is a touchy subject for a lot of DBAs. And I'm going to go over both our point of view and their point of view to hopefully make sense. Select star is basically shorthand for give me all the columns. I just want to see all the columns. So sometimes this is handy when you just want to see a set of data to see how they're storing the data. I mean, you might know what the column says, and it might be kind of cryptic the way the column is labeled, the column name. Maybe you want to see what kind of data is in there so you know how to query it for a report or an application. It's useful for grabbing an immediate result for review or analysis. Sure, especially in a dev environment, it's really handy. Where it becomes a problem is when developers will use it in an application such as this. Insert into table, select star from another table. This works. It works fine, it works great. But what happens when the original table drops a column? or adds a column. Something's going to break, which isn't bad. In your application, you might be trapping for that error. The problem is the answer you're going to get from Microsoft is an unexpected error occurred. Not all the columns are returned. An improper amount of columns are returned. It's going to be very vague. If instead you want all the columns, list all the columns. Select column A, B, C, D, E, F. When this breaks because they drop a column or add a column, it shouldn't break if they add a column. If they drop a column in the originating table and this breaks, it's going to tell you this column name doesn't exist. And you know exactly where to go to fix it. And they should have communicated that with you to begin with, but if and when they don't, you'll know exactly which column is missing. Then you can go to the DBA and say what happened, add it to your application, everything's going to work fine. The best practice, though, is insert into, select star from should not be used. List the columns. Select star is something we use very quickly just to get a sample set of data. And if you're going to do a select star, I would recommend either select top number star from so that you limit your row set, or in SSMS there's an option to give a row limit. You can also establish set row limit to in your query to limit the amount of rows you return. You can do a select count from, count paren star from table to get an idea of how many rows you're going to pull back. Because if this has 90 million rows in it, you say select star from, you're probably going to get a call from your DBA saying cut it out. Select distinct, another very touchy subject for DBAs. I've had a couple DBAs I talked to, they twinged when I mentioned this, but I think it's worth mentioning. Select distinct will return unique rows based on columns specified. We should also know that this is the same as group by. Essentially, they're pretty much the same, but they're not, and I'll explain why. It's shorthand style like select star is. This is a good way to think of it. However, if you're using select distinct in production code, you should be asking yourself, why am I doing this? If the answer is because every time I ran that query, I got duplicate results. So I only want unique results in my result set. So I'm going to use select distinct. Maybe you should use group by instead. The reason why is because the table could be improperly defined. Maybe you need an extra primary key or a foreign key identifier in there to further separate your data. Maybe there really is duplicate data in there, and it got snuck in somehow through an error or a bug, and you need to get rid of it. You're never going to know if you use select distinct because it's going to mask that. If you use group by, such as a select count and row column from table group by column having count greater than 1, you're going to see exactly if there's duplicate keys in there. But you're not going to see that if you use select distinct. Maybe the query just needs additional filter or group by criteria. Maybe you need to just add an extra join on in your joins. Maybe you need to switch the way the joins are going. Maybe it's just the way you're filtering and your join is constructed. There's a lot of opportunities to sit down with the DBA and discuss the way the query is constructed to see if maybe there isn't duplicate data. Maybe you're duplicating the data in the result set just by the way the query is constructed. The takeaway here is distinct and group by, from a performance standpoint, essentially do the same things. When you pull them both up in Query Analyzer or an execution plan, you're not going to see any difference. If any, it's going to be slight or negligible. The takeaway, though, is group by is recommended over distinct because you're filtering out, you're not masking the, you're not masking the possibility of true duplicate data in a table that may or may not, or might not supposed to have duplicate data in it. You might only need unique rows, and you're not going to know if you're using distinct. So I know this was a long one. The rest of them go a little quicker. But as a review, indexes, we should use them and maintain them. Even if we're not the ones maintaining them, the DBA should be aware of it so that they can maintain them in their regular jobs. Data types improve performance and storage. We should choose them wisely. Recovery models and logging. The choices you make on which recovery model you use will impact more than just your database. It also impact your application, your users. The difference between queries and views, complex queries and views. And also with using select star and distinct, we should know when to use each one. The next habit that I want to talk about is just good application habits. I'm only going to touch on 2 topics here, managing connections and sessions and using type safety and sanitizing inputs. Regarding managing connections and sessions, we should always ensure database connections are closed when no longer needed. Okay, that's pretty much common sense. We're done with the connection, let's close the connection. However, And this is a C# example. Take a look at this set of code. 3 lines of code, nice and simple. Connect to the database, execute the query, close it. Simple enough. But what happens if the connection fails on the second line? This is going to be left open forever. The reason why I brought this up, I had a DBA friend of mine who once told me, this application, there are a lot of people using this application. No, it shouldn't be used at all right now. Well, I have 90 or 190 connections open right now on that database. Close them. So you close them, they pop right open again. He's like, something's wrong. And this is what was going on. And you don't even realize it. You may not even realize it because sometimes in the process of coding, it happens to the point where this works fine in dev, and you completely overlook the fact that we should track that line here so that if something does happen, for whatever reason, unbeknownst to us, it doesn't leave the connection open. This would be an example of what to do in that case. Just use a simple try catch finally. Because what's going to happen here is if this opens up and this fails, this command execute non-query fails, it's going to get caught here. But even if it fails, the close is going to run. Because in a try catch finally, the finally always runs regardless of the outcome of the try. So if try works, finally runs. Catch runs, finally runs. It's always going to close the connection. This is the best way to ensure that the connection to the database is closed properly. Works in applications, works in mobile apps, works in websites. This is your best practice. And then here, of course, just depending on your solution, some friendly error, event log logging, flat file, whatever your choice is. Regarding type safety and sanitizing your inputs, we should always ensure the proper data type is being passed to the database. Excuse me. This should be, well, this is the best practice for preserving data integrity and preventing SQL injection, but the data type should be consistent from the application to the query to the database. I'm sorry. So from your front end, whether it's your application, your website, your mobile app, your client, your interface, whatever it is, that data type should be the same as your query, which should of course be stored procedure and parameterized in your code, expecting that specific data type. And then that should be passed on to your database where it's explicitly defined in your table construction or your stored procedure, where it's expecting that same data type. We should always use stored procedures instead of leaving the query in the code, because again, you have that centralized place where you and the DBA can go through your stored proc and make sure that it's constructed right, handle any changes that have taken place in the database, make sure the data types are set right, etc. The best practice recommendations are this. We scope the input field with the specific data type. This could be an HTML5 or you specify what it is. This could be your ASP.NET where you set your text field but qualify it with whatever the required field is in Ajax with the data type in it. I mean, there's so many ways of doing this. It's up to whatever environment you're writing in. We should use desired validation on fields. Again, so many ways you can validate information on a field. Use JavaScript, jQuery, HTML5, regex, totally up to you. We should call parameterized stored procedures, as we just indicated. Handle your errors in a friendly manner, a nice message on the screen, an event log message, etc. You don't want to take them back to that yellow screen of death. You're going to prevent improper data insertion and also empower your users to enter correct info, double check their entries, correct their mistakes, etc. It makes it a more engaging environment for your end users as well as make life easier on the DBA when you're not putting the wrong data in the database.
I have a question.
Yeah.
When you're pulling data, when your data comes in an Excel spreadsheet, and it really should be like numeric, but it doesn't hold the zeros, so you put it in text. What recommendation do you have so that you can have the versatility of grabbing the data and no matter which form it's in, and still put it in and process it?
I'll try to answer as quickly as I can.
Okay.
It should be, and we can talk about it after the session. I can give you a little more detail. But in C#, for example, the front end should be taking the data in and then in the code behind testing to see if it's convertible to a numeric, and if it's not, throwing an error to the screen saying, hey, this should be a number, or throwing an error to an event log saying I couldn't process this.
Okay,
And then if it is numeric, converting it to a numeric, padding with zeros if needed, and then processing that way. But yeah, I can show you some examples after the fact too, if it'll help.
yeah, thanks.
No, sure.
That makes sense.
Just as a quick review, we need to make sure sessions are closed properly. We can do that as simple as using a try-catch finally to make sure that no errors happen. And for type safety, input sanitizing, we should protect the data's security and integrity by making sure that the data type flows from the front end to the back end by using either filter criteria, validation, et cetera. Yes, sir.
On the connections, one consequence of leaving those open, every connection on SQL Server takes up 4K of memory on the server, as well as there's processing time for looping through to go, hey, anything happening here? But at a minimum, it's taking up 4K of memory. That doesn't sound like a lot. When you have a misbehaving application, that can add up.
Yeah, expect 9,000 transactions times 4K. They'll notice that. DBAs will notice that.
And I've even seen shrinkware apps that have problems like that.
See, it's a good point. Excuse me. The next habit I want to talk about, the third one, is what happens when we assume. Some common assumptions that we may have are resources are abundantly available. Maybe the DBA already knows what I'm doing. They sat in the requirements meeting. They heard what I was going to be doing. They know what I'm up to. And also, I don't need a dev test environment. It's working fine. That's a fun one. Resources are abundantly available. No, they're not. Let's assume you have a VM environment, not VMware. I'm not endorsing any specific one. A VM environment. It's a scalable architecture. There's plenty of CPU, RAM, hard disk space. The network team has assured you that you have whatever you need to do your job. Your application, if it's poorly performing or making improper calls, leaving connections open, etc., are going to consume resources. Throwing hardware at this is not going to solve your problem. All it's going to do is provide a bigger environment for your application to become this sucking vortex of resources. The important thing is to go back, work with your DBA, analyze the database, and assist with locating problems. And they can do that. They have the tools, the resources, and the knowledge to sit down and have you run your application, and they can monitor and say, this breaks here, this breaks here. You can go right back to your application and refactor it as necessary. Debug, assert, trace to find optimization opportunities would be your takeaway from that. When you sit down with your DBA, that would be where you go back, breakpoint, debug your code, figure out where they were talking about, because they're going to tell you exactly which queries are causing it, and then you can go back and fix them. DBA knows what I'm doing. They were in the requirement session with me. They heard what the project manager said. No, they don't know what you're doing. DBAs, some DBAs come from a developer background, some come from sysadmin. We'll go into this in a minute, but most of them are sysadmins in my experience. And sysadmins typically aren't coders. They're scripters, they're system administrators, they know the system, they know the servers, but they quiver when you talk about coding. You should always communicate what you're wanting to do. Even if they were a developer, even if they are fully aware of what you're doing, they're going to appreciate the redundancy of your conversation more than if you didn't tell them. How about I don't need a dev test environment? Yeah, you do. But it worked on my machine. I've used that, and I've heard it a lot. Each environment's different, and each company, each organization is unique. And depending on budget and other requirements, you may not have, the luxury of having a dev, test, pre-prod, and prod environment. I understand that. But you should always try to have at least one other environment as close to prod as possible. Identical would be best, including all service packs, cumulative updates, hotfixes, etc. So you can stage your application, your database, to make sure that it's as close to what it's going to be like as possible, so that you can work with the DBA in case there are issues. But you should always have a separate environment that you're working against. And it should be as close to, it should be as close to prod as possible. You should always be commenting stored procedures and views and workflows and your application so that the DBA and others know what was intended. This is what I was trying to do. This can help with troubleshooting or determining what's affected. If you're out one day and there's a problem with the server and they trace it back to one of your stored procs and you're not available, you can open up the stored proc, look at the code, and say, oh, well, in the comment it says, this is what I was trying to do. Now let me go back and see if I can help fix that. They might not have to bug you when you're on vacation. So, as a quick review, and yes, I changed the title intentionally. Resources are not abundantly available, and if you're told that they are, just pretend that they're not, because it's going to make you more efficient in the way you write your code. The DBA is not clairvoyant. Even if they sat in a meeting with you, discuss this with them, make sure that they know what your intentions were. There. And you most definitely need a dev test environment of some kind, even if it's a virtual machine on your laptop, something that you can work with independent of prod and your machine that you can write against that emulates productions that you're prepared. Bridging the role gap is the fourth habit I want to talk about. Like I said, your DBA is typically a former developer or a former sysadmin. They could be others, but typically, like I said. The main thing is just learn the background of the DBA, learn where they came from, learn their skill sets, learn where their limitations are, work with them regarding these skills and abilities, and keep an open mind. Oh, let me go back real quick. Because there could be skills that the DBA has learned when they went to school, when they had prior employers, that they can pass on to you, that they heard from their developers, that you could hear ahead of time and say, wow, I would never do that. I'm going to make sure not to do that. I'm going to make sure that they're aware that I don't work that way. I'm much more efficient than that. And it's going to establish that relationship, which is the final one I want to talk about, is relationships. You should be humble. The DBA doesn't know everything, and neither do you. I'm a huge proponent of the fact that no one's an expert in our field. Anyone who says they're an expert, you should steer clear from, because there is no such thing. Our technology, our environment, our languages changes daily. And there's always somebody who knows more than you. Always. And the sooner you learn that, and I'm sure we all understand that, but the sooner one learns that, it makes it a whole lot easier to work in the field. We should always ask questions when unclear. It's not a sign of weakness. Nobody knows everything. And be willing, no demanding resources, of course, but be willing to teach a little bit, because you might learn something back in the process. DBAs, a lot of times, if they're a sysadmin, love sitting down with developers to learn little tricks and tips on how to write quick little scripts and queries, PowerShell or otherwise, to make things more efficient. And in exchange, they might share some knowledge about something they picked up at a prior employer that'll make you more efficient in the way you write your code. It's always a trade-off. And always ask for help with logging during testing or troubleshooting, because they're there, they have the skills, they have the knowledge and the resources, and they want to help. The 5 habits reviewed are this. We should always ensure we're using proper data types, indexes, choosing the right recovery model, careful when using select star and distinct. Remember type safety and input sanitizing. Make sure you're handling that from the front end all the way through to the back end. What happens when we assume? The bottom line there, communicate with the DBA, and I think you can see the pattern for me. Communicate with the DBA, learn their skill set, understand where they came from. Any questions at all on what we've talked about? Yes, sir.
You talked about indexes and in fact how it can recommend missing indexes, adding them in. I've been working with the tuning advisor.
Okay.
And I just took for granted what it was recommending I should just do, and very similar to the way the indexes were recommended. And that was fine, but I found that it seems to be statistics and indexes is what it tends to focus on, I guess. But when we run the same thing on a different server, we might get similar index recommendations, but different statistics. So from a packaged software solution, when you want to make sure that when you're deploying it to your customers, it sounds, what I'm taking away from that is generally indexes will apply performance-wise regardless of the system that it's running on, if you want to generalize it to that degree. Right. And statistics do not, and maybe we leave statistics out of our planning of the schema and all that.
I think, I think I understand where you're going with this. I think the statistics are important as a value to a DBA who's trying to really narrow down issues with CPU, I/O, wait time, seek time, spindle use, etc., for managing hardware or virtual hardware. But from our point of view, consider it as a pre-index baseline and a post. Did you make an impact? Did the number go down? Yeah, you did something right. Okay, Did it go up? Okay, well, maybe I should go back and tweak that a little bit and add another column onto the index. Oh, now it went way down. Okay, I got a good one. Stick with that one. Just spoke with a contractor recently who was doing the same thing. And I had in mind to explain all the different values in that little pop-up window when you mouse over the select statement. He says, no, no, no. Just talk about subtree cost. Because he's been using this for years, and it's worked every time. Is that the rest of them are meant for DBA level server resource management, etc. So they're effective, they're important, and they're effective. But for our point of view, to keep things moving along, subtree cost is what you want to look at. What is the overall cost of this query? Did it improve baseline to now? There's no real number to say this is best, but if it went from 12 down to 0.07, you did something right. So absolutely, different environments are going to have different results, different tools are going to show different things, but the bottom line for us as devs is, did it improve? What kind of impact did you see? Something as significant as that? Yeah, you did it right. That's a good question though. Anything else? Yes, sir.
So if you move things into production, is there like a checklist that you should say they have to have it commented, they have to use the final statement, things like that?
I would recommend that the organization as a team sits down and says,
here are the disciplines that we want to...
Right, that you establish some type of, like I said, discipline, or what am I thinking of? I can't think of the word, but yes, it's something along those lines that says standards. Jeez, I can't believe I didn't think of that. Development standards. And in the development standards, you say, prior to going to production, this is handed off to whoever's going to release to production, and this has been done, this has been done, this has been done, and that can certainly be a part of it. Is the code well commented? Are the comments understandable? Is your code refactored into proper classes, etc.? I mean, depending on what the organization uses. There's no global accepted type. Yeah. It's highly customized based on the organization. Anything else? No. Well, I thank you very much. I'm sorry I ran a little bit over, but I thank you very much. Here's some resources that I use to get the information, and also some additional thanks to a couple guys that deserve it because they gave me a lot of feedback. And thank you also, David, for your feedback. That was great. And then the slide deck is available here, or also, I'll move out of the way so you can take a picture. It's also available on the SQL Saturday site for this event, SQL Saturday 279. And again, if you're social, there's my Twitter handle, my blog, which I update. I need to update more, but I do update at least once a month. And then if you need to contact me for anything, my email address is up there. I want to thank you very much for attending. If you could, fill out the little questionnaire forms and hand those in, and have a great rest of the day.